I wanted to show you guys another video about synthetic division, and I wanted to focus on the theorems that we were talking about. The factor theorem and the zero remainder, how they work together, why I am calling it a factor of the polynomial if the remainder is the zero. So one of the best ways I thought I could explain this is this information that you guys already know, the sum and the difference of perfect cubes. And I wrote the basic formulas for the sum and the difference right over here. Under it, I put an example. So x to the third power plus 27 from the perfect cubes, the sum of the perfect cubes rule, it basically looks like x to the third power plus 3 to the third power, because 27 is 3 times 3 times 3. So I can write this as first binomial x plus 3 multiplied by a quadratic equation x squared minus 3x plus 9. Compare these two and you will see what I'm talking about. So according to this then, x plus 3 times x squared minus 3x plus 9 gives me x to the third power plus 27. We know this. So these two are factors of the perfect sum, the sum of perfect cube that I have over here, x cubed plus 27. So if I divide x to the third power plus 27 by x plus 3, my answer should be x squared minus 3x plus 9 with no remainder. So let's see if that's going to be the case. Alright, so here is the example that we were talking about. I just set this up in the synthetic division setup, and as you guys realize, I have two zeros in green, which represents I don't have an x squared and I don't have an x term in my dividend. So I have to write those values as 0 and 0. I have to put this in standard form, and if I don't have a term, I have to replace the value with 0. The next is the first term comes down. But before that, look, I'm dividing by x plus 3. So the whole idea of this x minus c, I have an x plus 3 equals 0. So my x equals negative 3. That's why I'm working with negative 3. So 1 times negative 3 is negative 3 plus 0, negative 3. Negative 3 times negative 3 is positive 9. 0 times 9 is 9. And 9 times negative 3 is negative 27. And when you add, it is 0. So according to this, x squared, x to the third divided by x, I should have x squared starting my term. So I have 1 x squared minus 3x plus 9 as my answer. Obviously, we don't need to write this 1. So when I divide, my quotient is this. And look over here, my remainder is 0. Because the remainder is 0, x plus 3 is a factor of the polynomial x to the third power plus 27.